Both the Building Analyst and BPI 1200 standards provide information about estimating energy savings. Part of this process is estimating the R and U values of building components. The BA standard provides detailed guidance on this step, including tables for estimating insulation R values and window U values. BPI 1200 does not. Let's take a look at the details. The Building Analyst standard doesn't require energy modeling or hand calculations to estimate heat loss and energy savings, but it acknowledges that it's commonly part of an energy audit, and it provides guidance that's useful in completing these calculations accurately. We'll look more closely at the details later in this lesson. The BPI 1200 standard states explicitly that cost-benefit analysis must be performed. It also lists 5 acceptable methods for performing the calculations. You can read those on your own if a specific method is not required by your program. BPI 1200 also states that while detailed measurement of components and insulation levels are optional, adequate detail to ensure accurate savings estimates is required for specific home energy upgrades that are recommended for action. However, BPI 1200 doesn't give any guidance on how to accurately determine the effective R value of building components. The BA standard, on the other hand, provides detailed tables that allow auditors to quickly estimate the R values of the most common insulation materials. The standard states that R values of installed insulation shall be determined based on actual measurement of the insulation depth and the R value per inch for that product. This is followed by a table that lists the typical R value per inch of 13 different insulation types. You may have noticed an asterisk on the chart related to fiberglass bat evaluation. It directs you to an additional chart for this common insulation material. A table on the next page of the BA standard provides clear directions for determining the effective R values for bat insulation. These values are significantly lower than the theoretical R value listed on the prior table, since it accounts for the inevitable gaps, compression, and other imperfections that are typical of bat installations. These insulation tables are very useful, and they're based on industry standard resources such as ASHRAE documents. This information is not included in BPI 1200. The BA standard also provides helpful guidance for estimating the thermal performance of windows. It says that the NFRC label should be used to obtain this information if it's still present on the window, but it rarely is. In that case, the standard says, where the NFRC numbers are not available, use the following chart to estimate the U value and solar heat gain coefficient. Let's take a look at this table. It's very helpful to have an easy reference that allows you to estimate the important performance factors from visible attributes of the window assembly, like the frame material, number of panes, and the presence of a low E coating. Again, BPI 1200 does not provide comparable information. From this review, it's clear that significant information helpful for estimating the thermal performance of building components is lost in the transition from the Building Analyst standard to BPI 1200. But at least for now, this information is still available in the BA standard. So even if your program adopts BPI 1200 as the official reference for audits, it may be worthwhile to keep a copy of the BA standard available simply to use these R value and U value charts.